I'm going to try to get right to it. I'm in a bit of a hurry. I wasn't planning on making videos today. I was just going to be teaching you guys the lesson tomorrow, but I may be going up to the hospital tomorrow, and I want to make sure I get you guys what you need. So anyway, beginning of chapter 10, we can see we have parametric equations, and that's what we're going to focus on today. I wrote vectors and polar here because that's what we're going to be focusing on for the rest of chapter 10. In fact, this is your last chapter, in case you had not realized that. We are in our last chapter of the entire book, and over the next 3 weeks, that's what we're going to be covering. And before we actually start filling out this note page, I wanted to make sure that I helped you understand that in the past what you've done and then what we're actually be focusing on. So this is the past. You guys have done motion in 2 directions. You don't have to write this down. You've done motion along a line. Typically, it either goes left and right, up and down. Sometimes you say we go forward and backward, where there's a particle moving along a line. And we did that in section 3.4 in the calculus book, the PVA problems, position, velocity, acceleration. And if we, say a position here, and then if the particle's moving to the right, we say the velocity is 0. Particles moving to the left, the velocity, did I say 0? Velocity is greater than 0 for the particle moving to the right. So we have movement, we have velocity, acceleration, and that we still have that when we're dealing with motion, but today, and in this chapter 10 really, we have motion in the XY plane. And take for example, if we had this, let's say we start right here, and we put a bug on our piece of paper, and the bug starts walking around. The bug might carve out a curve like that, or bugs aren't always just going to move left and right, up and down, forward and back. Okay, so given that example, hopefully you can see the difference between the motion that we used to do, which we will still do, but the motion now, and we can use vectors and parametric equations to describe things about the motion, things about the particle or whatever that's moving in the XY plane. Okay, so let's go ahead and I'd like you to actually draw this, just draw a curve similar to what you see here, and I'll pause for a moment while you do that. Do it really quickly because I don't want to pause too long, have you fall asleep on me. But there, I'll circle chapter 10, I'll double underline start, and I'll put a little star right there where we're starting. So I'm stalling right here, and so that's about it. So we have motion in the XY plane. The motion, just to keep in mind, the motion is going to be like this. I'm indicating with arrows that this bug, we're just going to continue to follow the bug all the way around, and we've got these arrows. And again, I am stalling a little bit, I'll admit that. And so we get arrows. That makes it look a little bit nicer anyway. So you can see the motion here in that direction. So I am going to also ask you to place a couple points along the way, some key points that we're going to talk about. So let's put a point down here at the bottom of this, like at the lowest most point. Let's put another point up here at the uppermost point, and then let's see, another key point would be something along these lines right here, and we'll talk about that in a second. Let's label these A, B, C, and oh, we need to make sure we put another point over here, the rightmost point, that's D, the leftmost point here, E, and then a point that's not a highest or lowest point, and we're going to call it F. Okay, and so I really just want to help you understand conceptually what is going on when we're talking about motion in the XY plane. Okay, specifically with parametric equations, and let's see, where do I have some room here? Parametric equations, just to remind you what we have, what you've learned already. If you watched the videos that I made for Pre-Calc Honors, great, then you should be familiar with parametric equations in which x and y are both dependent variables and dependent upon a parameter. That's why they call it parametric equations, a parameter t, where you can make a t, x, and y chart, and you can see, you pick values of t, and x and y both depend on t. Whereas before, when you dealt with rectangular relationships between x and y, typically you had y as a function of x, in which x was the independent variable and y was the dependent variable. Well, here x and y are both the dependent variables, and t is your independent variable. And you have graphed functions using your calculator, I think, in pre-calc honors. And anyway, I wanted to talk about little tidbits of information here about point A. Let's say, well, in fact, let's give point A the coordinates x of 1. Let's say at 1 second mark, the A has the coordinates x of 1, y of 1, where x and y both depend on t. So at the t, where's my red? I really need a red right now. So at the time when at t equals 1, t equals 0 is where we start. T equals 1, we're at point A. Let's just say at t equals 2, we're at point B. And let's say at t equals 3, we're at point C. Let's just say. It doesn't really matter what the t is, what time we're getting there. It just helps us identify what we're talking about. So if by chance A is where the particle has moved to at the end of 1 second, then we can say things about x prime. Now remember, x prime of 1 represents the rate at which the horizontal distance, or the horizontal movement, is changing, okay? Or the horizontal position, we should say. The rate at which the horizontal position is changing at that precise moment, okay? So let's try to understand this here. If the particle is moving along this curve here, then let's just keep our analogy of the bug. If the bug is moving along this path, then we would say that the horizontal rate of change is positive at that time. Okay, the horizontal rate of change. It's moving to the right. Okay, yes, it's moving down, and it's moving down, so we would say the rate of change of y then would be negative. Okay, so you get that? Good. I could hear you speaking to me through the computer. And so that would be one way to describe the motion there. And let's look at B, at point B. Okay, we would say x prime at 2, which is when the particle is at point B. X prime at 2, we're still moving to the right, and so you should identify that x prime of 2 is positive. But what about y prime at 2? What's going on there? We're at our lowest point here. And remember, the derivative of a low point or a high point would be 0. The rate of change of the vertical distance now. Okay, so the tangent line would be horizontal here, and if a tangent line is horizontal, then the change in y is equal to 0. Okay, I really need my red. I really wish I brought that. Very sorry. I'm sure that's really bothering you. And so we can do the same for point C. All right, so B again is this point here. This is the A up there. And then let's look at point C. And I challenge you to indicate what the x prime at 3 is and what the y prime at 3 is. Okay, so I challenge you to find that. Okay, so if you want to think about it, then pause the video. We are at point C. So if you look at point C, you would notice again that x prime is greater than 0 because it's still moving to the right. And then y prime at 3 would be equal to 0. Okay, well, that both at B and C, we hit a high point at C and a low point at B. Okay, let's try one more, and let's try F. I challenge you right now to indicate what the derivatives are, and let's just say when we get to F, it's like at t equals, let's say 12, at the 12-second mark. Okay, so at point F, that would be x prime at 12, so our horizontal rate of change and our vertical rate of change. Okay, so compare these to 0. Is the horizontal rate of change positive, negative, or is it equal to 0? And same with the vertical rate of change. Okay, and the vertical rate of change, well, we'll get to that. Horizontal rate of change would be, now we're going to the left, so that would be a horizontal rate of change is negative at that point F. Now also we're going down a little bit. I told you that. So the high point is right up here to the right, and then so we're moving to the left here and we're going down. So both x prime and y prime at point F are negative. And so this is really useful And eventually you'll see that we can actually calculate the rate, the speed at a certain point along the curve given the parametric equations. We'll use vectors, and it's kind of a neat thing because you use a lot of what you've learned already and you put a lot of meaning to what you're learning now. So let's go ahead and get our note pages back, and if you need more help with those, please let me know. Send me a message and I will clarify some things for you. Again, I'm going to hopefully be in the hospital tomorrow, so I'll be able to be online and give you some help if you need help. So please let me know if you do. I'm noticing here I'm past 10 minutes, so I'm going to stop this and start up the notes in the next video.